Righto, so that last video left you wondering, the y value that we found was actually the z value technically, because that was from the equation z equals x plus whatever it was over x to the 4. So yeah, that was what we actually found there. Anyway, I'm going to go on with this next question. So a cylindrical canister closed at both ends has a total surface area of 100 centimeters squared. Find the greatest volume it can have, and if the radius can be at most 2 centimeters, what will be the maximum volume? So I guess one of the key points here is that you need to know all of your equations for the total surface area and volume of different shapes. And I'm going to write the ones just here that we need. So first off, we need the total surface area of a cylinder, which is 2 pi r squared, because that's the two circles on the end, plus 2 pi rh. That's the rectangle wrapped around the outside of it. We also need to know the volume of the cylinder, which is pi r squared h. So you notice this here technically has 4 variables. We've got total surface area, we've got radius, we've got height, we've also got volume. So this is just a total mess. But we know that total surface area is 100. So I can sub that in. 100 equals 2 pi r squared plus 2 pi rh. Now, what I'm thinking to do at this point is get all of this equation here in terms of h, all in terms of r, so I get h in terms of r, and then sub it into the other equation over here. So, first thing I'm going to do is I'm going to minus 2 pi r on both sides. So I'll have 100 minus 2 pi r squared equals 2 pi rh. And now I'm going to divide by 2 pi r on both sides. So h is all that will be left on the right hand side. 100 divided by 2 pi r, well, the 100 divided by 2 makes it 50 divided by pi r. And 2 pi r squared divided by 2 pi r, well, the 2's will cancel out, the pi's will cancel out, and one of the r's will cancel out, leaving us with just minus r. So I've got h in terms of r now, which I can sub into the volume equation. So that's going to give the volume is equal to pi r squared multiplied by 50 over pi r minus r. And if I expand that out, I can probably make it look a little bit better. So, well, with the first one, the pi is going to cancel out, one of the r's is going to cancel out, so we'll be left with just 50r minus pi r squared multiplied by r is pi r cubed. So we've got the volume in terms of the radius, and now we can use calculus to find out what the maximum is going to be. It's also going to have a minimum at some point because it's a cubic equation, and it's a negative cubic, so I mean, if I draw the shape of the graph, it's going to look something like that. And so we can see that our maximum point is going to be this one right here on the right hand side, whereas the minimum would be the value on the left hand side. So what I'm going to do is I'm going to do dv dr, and in differentiating this I get 50 minus 3 pi r squared. And for a maximum or minimum, we let dv dr equal 0. So that means that 0 equals 50 minus 3 pi r squared. Adding 3 pi r squared on both sides, we get 3 pi r squared equals 50. Dividing by 3 pi on both sides, we get r squared equals 50 over 3 pi. And then taking the square root of both sides, we get r equals plus or minus the square root of 50 over 3 pi. Now at this point we have two answers. One of them is a maximum, the other one is a minimum. And as we said before, the maximum will be the one on the right hand side because of the shape of the graph. So that means that the positive one is going to be maximum. Also, the left one is a negative value, it will be negative root 50 over 3 pi. And the radius can't be a negative number, so we can reject that solution. I'm going to continue this in the next video.